This week we're going to be focused on the unit circle. Last week we focused mostly on trig functions in the coordinate plane where our angles were represented in degrees. This week we're switching the focus more to radians. And the big goal of the week is to be able to memorize the unit circle and to be able to evaluate the 6 trigonometric functions on the unit circle quickly from memory. All right, so the first thing we're going to do is convert radians to degrees. There are pi radians is the equivalent of 180 degrees or a half circle. To convert degrees to radians, we will multiply by pi over 180, and to convert radians to degrees, we'll multiply by 180 over pi. So looking at this first example, converting 45 degrees to radians, we are going to multiply that by pi over 180. Now I can reduce this because 45 goes into 180 4 times. So if I divide both of these by 45, I get 1 and 4. So I end up with pi over 4. And in the next one, same idea, multiply by pi over 180. And I'm going to reduce the 300 over 180. You might want to do it in steps. Maybe we'll just cancel out those zeros and get 30 pi over 18. And then 30 and 18 are both divisible by 6. So if I divide them both by 6, I'll get a 5 and a 3. And so we end up with 5 pi over 3 radians. In the next part, we're going to convert radians to degrees. So we multiply by 180 over pi. And I remember that the pi needs to go in the bottom because it needs to cancel the pi that's on the top. So the pi's will cancel, and we end up with 3 times 180 over 2. And I could divide 180 by 2 and get 3 times 90, which is 270 degrees. And then in the next one, same thing, times 180 over pi. The pi's cancel, and we get 11 times 180 over 6. I'm going to divide 180 by 6, and that's 30. So we get 11 times 30, which is 330 degrees. In this next part, we're going to draw some angles in their standard position from radians. So pi over 2 is half of, remember that pi is the same as 180 degrees, which is the half circle. So pi over 2 is 1/2 of a half circle, which is going to be, well, remember our initial side is always on the x-axis, and the terminal side will be right here. Pi over 2. 5 pi over 6. If you divide pi, that half circle, into 6 parts, you would have 1 part, 2 parts, 3, 4, 5, 6. That would be dividing pi into 6 parts. 5 pi over 6 would be here. And then I'll erase my other lines. So that would be 5 pi over 6. Okay. And the next one, 7 pi over 4, if we divide pi into fourths, that would be 1/4, 2/4, 3/4, 4/4, and then keep going, 5/4, 6/4, 7/4. That should be a 45-degree angle. I didn't draw that very well. That would be 7 pi over 4. And I'll erase these lines. Okay, then negative 2 pi over 3. Now we're working in thirds. So, but we're also, for a negative angle, remember we swing down. So if pi is half of a circle, and I divide it into thirds, that would be, I didn't mean to use a highlighter there. That would be 1/3, 2/3, and 3/3. So negative 2 pi over 3 would be here. And I'll erase the rest of this mess. And that would be those angles drawn in their standard position. And for all of the angles, the initial side was on the positive x-axis. Now it's time to get to know the unit circle. The unit circle is a circle in the coordinate plane with a radius of 1. So every radii drawn in that circle is 1 unit long. And so if r becomes 1, our 6 trigonometric functions get a little simpler. Sine is still y over r, but if r is 1, sine of theta becomes just y, just the y coordinate of the point. Cosine of theta, x over r, becomes just x. And tangent theta is still y over x. Cosecant is the reciprocal of sine, so it's 1 over y. Secant, the reciprocal of cosine, is 1 over x, and cotangent is x over y. Now we're going to start off filling in the degree measures of this circle because we're pretty familiar with degrees, so we'll start there. So we've got, the initial side is still on the positive x-axis for all of our angles. So a 0-degree angle would be right here. And then as we go around, we're going to memorize these values: 30 degrees, 45 degrees, 60 degrees, 90 degrees. And then if we keep going, add another 30 degrees to that, we get 120 degrees. Right in the middle between 90 and 180, add 45 to 90, and we get 135. And then our next angle is going to be 150 degrees, and then 180. And we keep going around, add 30 degrees to that. I'm going to add increments of 30. So if I do add 30 to 180, we get 210. Adding 30 to that gives us 240. Adding 30 to that gives us 270. Adding 30 to that gives us 300. And then we have 330. And then I skipped my 45-degree angles. So 180 plus 45 gives us 225. And then 225 plus 45 is 270. 270 plus 45 is 315. And 315 plus 45 is 360 degrees, a full circle. So 0 and 360 are obviously two different ways to represent the angle whose terminal side is on the positive x-axis. Okay, so those are the angle measures in degrees. And now we're going to switch to radians. So for radians, 0 is still 0 radians, and 180 is the same as pi. So I'm going to jump over there. Now, if I divide pi in half, so dividing the unit circle into halves, like half of the half circle, that would give me pi over 2. And then pi is the same as 2 pi over 2, which reduces to pi. And then adding another pi over 2, we get down here to 3 pi over 2. And then adding another pi over 2, this would be 4 pi over 2, which reduces to 2 pi. Next, I'm going to divide my unit circle into thirds of a pie. So if we divide it into thirds, remember that the pi is 180 degrees. 1/3 of a pi would be here, a 60-degree angle. 2/3 of a pi would be a 120-degree angle. So that's dividing pi into thirds. And then if I keep going, it would look like that. Okay, so 1 pi over 3 is here. 2 pi over 3 is in quadrant 2. 3 pi over 3 reduces to pi. 4 pi over 3 is here. 5 pi over 3 would be in quadrant 4. And 6 pi over 3 reduces to 2 pi. Now we're going to divide the unit circle into fourths and look at our pi over 4 parts. So if we divide pi into 4 parts, that would be 1, 2, 3, 4. So that would be dividing it into fourths. And then if we kept going, we'd get 5, oops, not there, 5, 6, 7, and there would be 8 fourths total. So pi over 4 is the 45-degree angle. 2 pi over 4 reduces to pi over 2. 3 pi over 4 is our 135-degree angle. 4 pi over 4 reduces to pi. 5 pi over 4 is the 225-degree angle. 6 pi over 4 reduces to 3 pi over 2. 7 pi over 4 is our 315-degree angle. And 8 pi over 4 is the same as 2 pi. And now our last part is dividing pi into 6 parts. So this would be 1, 2, 3, not there, 4, 5, 6. And then if we kept going, there would be 7, 8, 9, 10, 11, 12. So we get pi over 6 is the 30-degree angle. 2 pi over 6 reduces to pi over 3. 3 pi over 6 reduces to pi over 2. 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6 is our 150-degree angle. 6 pi over 6 reduces to pi. 7 pi over 6 does not reduce. 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. And then 11 pi over 6 is our last angle. So that's all of our angles in both degrees and radians. We need to memorize where they are, and if we understand where it comes from, that is helpful, of course. All right, now the coordinates of these points. Remember that each radius is 1 unit. So on the right side over here, we're going to have the coordinates 1, 0, because it's 1 unit to the right of the origin. Our angle pi over 2, or 90 degrees, is straight up 1. That's the coordinates 0, 1. And pi, or 180, the coordinates are going to be -1, 0. And then 270, or 3 pi over 2, is going to be 0, -1. So those are our quadrantal angles that are multiples of 90 degrees. They're on the axes. Now our next angle, well, the 45 degrees aren't so bad. This comes from, we could calculate it by making a triangle. If you make a 45-degree angle, that's an isosceles right triangle, where this is 1, we end up with getting the square root of 2 over 2 for both the x and y component using special right triangles. So the coordinates of pi over 4 or 45 degrees are going to both be root 2 over 2 for both x and y. Now in quadrant 2, it's the same, the 135 degree angle is going to be the same thing. It has the same 45 degree reference angle, but the x coordinate is negative. So it's negative root 2 over 2, and then y is positive root 2 over 2. In quadrant 3, both the x and y are negative, so we're going to have negative root 2 over 2 and negative root 2 over 2 for the 225 degree angle, or 5 pi over 4. And then in quadrant 4, x is positive and y is negative. So it's positive square root of 2 over 2 for x and negative square root of 2 over 2 for y. For our 30-degree angle, if we make a 30, 60, 90 triangle, where the hypotenuse is 1, the shorter side is going to be the square is going to be 1/2, and the longer side is going to be the square root of 3 over 2 using special right triangles. So the x coordinate for our 30-degree angle, or pi over 6, is square root of 3 over 2, and the y coordinate is 1/2. And for the 60-degree angle, or pi over 3, it's the same thing but reverse. It has the shorter x coordinate of 1/2 and the longer y coordinate root 3 over 2. And it's really the same in the other quadrants, but the signs change. So if we look at our 120-degree angle with a short x that's negative, it's going to be negative 1/2, and then positive root 3 over 2 for y. Our 150-degree angle, or 5 pi over 6, has a longer x, and it's negative, root 3 over 2, and a shorter y, which is 1/2. And then in quadrant 3, both x and y are negative. 7 pi over 6, or our 210-degree angle, is going to be a long x, so negative root 3 over 2, and a short y, negative 1/2. 240 degrees, or 4 pi over 3, is going to be a short x of negative 1/2 and a longer y, negative root 3 over 2. 300 degrees, or 5 pi over 3, x is positive and it's shorter, so it's 1/2. Y is longer, negative root 3, and it's negative because it's down below, so negative root 3 over 2. And then the last one, our 330-degree angle, or 11 pi over 6, has a longer x, and it's positive, root 3 over 2. Y is negative 1/2. And then one last thing, we need to make sure we think about the signs of each of our trig functions in the quadrants. So in the first quadrant, where both x and y are positive, all 6 trig functions are positive because you have a positive x and a positive y. In quadrant 2, you have a negative x and a positive y. So cosine and secant are going to be negative. Sine and its reciprocal cosecant are going to be positive. And then tangent, since it's y over x, is going to be negative, and cotangent is x over y, it's going to be negative. In the third quadrant, sine and cosine, or the x and the y, are both negative. So sine and its reciprocal cosecant, cosine and its reciprocal secant are all negative, but tangent, since it's y over x and cotangent's x over y, those both come out positive. And then in quadrant 4, where you have a positive x and a negative y, cosine is positive, its reciprocal secant is positive, sine and its reciprocal cosecant are negative, and then tangent and cotangent also come out negative. Now we're going to use the unit circle to evaluate trig functions for different angles, and we should be able to do this from degrees or radians, particularly radians. Okay, now we're supposed to be able to do this without looking at the unit circle, but to begin with, it helps to have one handy. So if we're going to find cosine of 135 degrees, we are looking right here in quadrant 2. Cosine is going to be the x-coordinate, and so that's negative root 2 over 2. Sine of 5 pi over 4 would be the y-coordinate, which is also negative root 2 over 2. Tangent of pi over 4 is going to be y over x, root 2 over 2 over root 2 over 2. Anything over itself is 1. Cotangent of pi, remember cotangent is x over y. So cotangent of pi is going to be negative 1 over 0, which is undefined. Cosine of negative 60 degrees. Remember, for a negative angle, you swing down. So negative 60 degrees, if you start here and swing down 60 degrees, is going to be the same as 300 degrees if it were a positive angle. And then cosine of that angle is the x-coordinate, which is 1/2. Tangent of 5 pi over 6, right here in the second quadrant, is going to be y over x, which is 1/2 over negative root 3 over 2. And the more we do these, we start to memorize these values, or they at least become pretty quick. This is the same as 1/2 times negative 2 over root 3, which gives us, well, the 2's cancel, negative 1 over root 3, but we're not allowed to leave a radical in the bottom, so we multiply by radical 3 over radical 3, and we get negative root 3 over 3. Cosecant of 9 pi over 4 is going to be 1 over y. Remember, it's the reciprocal of sine. So 1 over the y-coordinate. 9 pi over 4. Well, remember, 4 pi over 4 would be 1 pi. 8 pi over 4 would be 2 pi, a full circle. Sorry about all the screaming in my house. So 9 pi over 4 is 2 pi more than pi over 4, which would be coterminal with pi over 4. And so our coordinates there are both x and y are root 2 over 2. So 1 over that, or the reciprocal of that, would be 2 over root 2. But we can't leave the radical on the bottom, so multiply by root 2 over 2, and we get 2 root 2 over 2. The 2's cancel, and we just get root 2. Now we could make these a little more complicated. Secant of 7 pi over 3. Well, 6 pi over 3 would be 2 pi, which is a full circle. 1 more pi over 3 would be 7 pi over 3 is coterminal with pi over 3. So secant is 1 over the x-coordinate, which is going to be the reciprocal of 1/2, giving us 2 over 1. Tangent of negative 5 pi over 4. Negative 5 pi over 4, if I swing down, 4 pi over 4 is a half circle. 1 more pi over 4 would be coterminal with 3 pi over 4. Tangent is y over x, and since the x and y coordinates are both root 2 over 2, but one's negative, that's going to give us negative 1. And so we end up with 2 times negative 1, which is negative 2. And for part F, secant squared of 7 pi over 4. Secant of 7 pi over 4, first let's find 7 pi over 4. It is down here in quadrant 4. Secant of 7 pi over 4 is the reciprocal of cosine. So it's going to be 2 over root 2. And we had that before. That came out to just be root 2 when we put it in simplified radical form. So secant squared of 7 pi over 4 means the square root of 2 squared, which is 2. And then tangent of pi over 4 is root 2 over 2 over root 2 over 2, which is 1. So we end up with 2 over 1, which is 2.